yellow, you've got 2 minutes.
Thank you. Thank you, Mr. Chairman. Good morning, everyone. I'm about to show you a study we have carried out at the University of Bari in Italy. The first mention of hypostasis is found in literature from 16th century. At the beginning, labor mortis was underestimated, and it was used only as a certain sign of death. Later on, pathologists understood that there was a correlation between hypostasis features and post-mortem interval. The problem is that the hypostasis onset and extent can be affected by several external and internal factors with variation of blood volume and density. From 1930 on, some authors postulated theories on hypostasis valuation, but no one defined precise instruction to test it. The first step of our study was to understand how hypostasis is tested in daily practice. We prepared a questionnaire on hypostasis testing with a map of lividity in supine position. Then we administered this questionnaire to 35 forensic pathologists and fellows in training. The first question was, where do you usually test hypostasis? And the most frequent answers were area number 8, 17%, and number 9, 14%. Then we asked pathologists which finger they used to test hypostasis, and we discovered that the right hand index finger and thumb are the most frequent used fingers. With regard to pressure used, the majority of people said that use strong pressure. When we then used digital scales to calculate how much pressure each pathologist applied when we asked them to use light, medium, and strong pressure. We obtained the following average values. Light pressure was 1.52 kilograms, medium pressure 2.66 kilograms, strong pressure 4.34 kilograms. We also asked how long they kept pressing, and results showed that each person pressed for different amounts of time. After this preliminary step, we performed the experimental part of our study. We used a dynamometer to apply defined pressure, a chronometer to calculate the time of each pressure application, a colorimeter to evaluate the color of skin prior to or after pressing. We also created a form to fill in with all data. We defined specific classes of pressure and pressure application time using the observational data obtained after the questionnaire. We filled in forms with the data obtained from each case, personal data, cause and time sim death, a picture of cadaver's posterior surface, skin color measurement in blanched areas that we call blank value, skin color measurement of lividity in selected areas, skin color measurement of blanching after each pressing in each area, timing of refilling after pressing, and calculation of the difference between HN and B. We studied 102 cadavers, 101 adults, and 1 infant who died at the University Hospital of Bari. The group was made up of 49 males and 53 females. We defined 7 age groups from less than 1 year to more than 81 years. Environmental temperature varied from 9.4 degrees centigrade and 23.5 degrees centigrade. Humidity ranged from a minimum of 27% and a maximum of 84%. Postmortem interval was known in all cases. Body size was described as 5 weight groups: severely underweight, underweight, normal weight, overweight, and obese. Causes of death included many groups: tumors, cardiovascular disease, infectious disease, kidney disease, gastrointestinal and dysmetabolic diseases, as well as neurological diseases. We were able to follow up the validity and record our measurement more than once in only 8 cases. From a qualitative point of view, we describe the hypostasis as absent, less marked, normal, or intense. PMI ranged between 30 minutes and 23 hours after death. Here is an example of our test. As you can see, this is the picture of the back of the cadaver with the form filled with skin curl values. We performed these measurements on all areas. This was an 88-year-old obese female. She dies of hypotensive shock 6 hours and 20 minutes before our test. Environmental temperature was 9.7 degrees centigrade, humidity 58%. Liver mortis was intense and a blank value of 0.408 optical density and a refilling time of 1 minute and 30 seconds. In this graph, lines represent the number of tests for each pressing needed to obtain blanching in each area. Blue lines describe a constant decreases of the number of tests. This suggests that no factors affect measurements. Here is another case where you can see a difference in the graph trend. In fact, gray lines describe a variable decrease of the number of tests. This suggests that some factors affect measurement, as the presence of navy, spots, and hair that alter the colorimeter measurements. From an observational point of view, we know that hypostasis was mobile or confluent when we need a low level of pressure and a short time of application to reach blank, and when refilling time was less than 60 seconds. Instead, liver mortis was nearly fixed when a high level of pressure was necessary along the medium time of application to reach blank, and refilling time between 60 and 120 seconds. Finally, we consider fixity when pressure needed was higher than 2.7 kilograms per square centimeter, and time of application was 7 to 10 seconds, with a refilling time of more than 120 seconds. For statistical analysis, we decided to study only data from area number 4. This choice was due to the higher probability of hypostasis onset in this area, and to the observation that area number 4 was more easily detectable with colorimeter than other areas. That was because of low pressures of air, skin spots, and surface irregularities due to both. So from a total of 102 cases, we restricted our sample to 86 cases because 16 cases didn't present lividity in area number 4. Here is an example of our analysis. First of all, we collected the data and filled in the form with skin color measurements after pressing. Then we calculated the difference between this value and blank, delta n. Our cutoff was plus or minus 0.07 from blank. Cycled values correspond to delta n, equal plus or minus 0.07 for each pressure class. Another table was created with the amount of pressure needed to reach delta n equal plus or minus 0.07 for each application time class. We performed linear regression with PMI as a dependent variable. Our independent variables were points C and D from the previous slide. Statistical analysis allowed us to define that a pressure of 1.5 kilograms per square centimeter and 3 seconds application time are the most statistically significant, with p-value of 0.007 and 0.005. So we can say that our study suggests a standard combination of pressure and application time, 1.5 kilograms per square centimeter for 3 seconds. In conclusion, we propose a protocol that is based both on observational and instrumental methods. First of all, we don't want to decrease in any way the importance of traditional evaluation of validity, visual assessment and application of finger pressure. But in any case, we suggest filling in a specific reason may be affected by subjective criteria. So in the near future, we hope it will be possible to standardize this assessment by creating a new device with a colorimeter, a dynamometer and chronometer all together. This will be the first step in creating a formula to calculate PMI using standard pressure and application time values.